Hello and welcome to my shop. Some time ago I had to cut a fairly large thread in steel on my small lathe. It was a copy of a DIN 800 spindle nose with a pitch of 5.5 millimeters. A suitable change wheel combination was quickly found, but the usual thread cutting methods were not employable on the small machine due to the required width of the cuts. In this video I will present a method which allows cutting threads of any size, even on mini-lathes, at least in theory. Let's start with a little bit of boring theory. For cutting threads, you can of course simply feed perpendicular to the axis of the workpiece between the individual passes, either with the cross slide or with the compound slide rotated by 90 degrees. The red line shows the required cutting width, which is more than twice the depth of the thread. Even with minimal infeeds, you will soon reach the limits of a small machine. So far, so familiar. The problem can at least be reduced if the cutter is not fed perpendicular to the axis of rotation, but at 30 degrees parallel to one of the cutting edges of the tool. In the Anglo-American world, the compound slide is often rotated accordingly. The infeed then takes place exclusively with the compound slide. The diagram shows that the chip width can be roughly halved using this method. Again, so far so familiar. However, this procedure also has its limits due to the cutting width increasing proportional to the thread depth. But there is a simple solution. Let us briefly consider the production of a deep V-shaped groove. Here you can first simply plunge in vertically and then peel off one of the flanks with the compound slide set to a 30-degree angle. Theoretically, this can be done to any depth with small cutting widths. Of course, continuous infeed is not possible when cutting threads. Here, step-by-step infeed is required between the individual passes. Thus, we start with one or more cuts with perpendicular infeed. The tool is then moved in a longitudinal direction. Starting from this position, the compound slide is used to feed between the individual passes. This is repeated until the desired thread depth is reached. The section highlighted in red shows that the cutting width does not increase with the thread depth, but only depends on the offset in the longitudinal direction. So, enough talk. Let's make some chips and take a look how this works in practice. Firstly, the top slide is set to minus 30 degrees. For the following demonstration, I will use a piece of aluminium, which I have already set up here. I use a single point screw cutting tool ground from high-speed steel, which I align with the fishtail gauge. I start with the usual scratch pass to check the thread pitch, in this case 4.5 millimeters. The first passes are simply cut with perpendicular infeed, so nothing special up to this point. The next step is slightly more complex, as the cutter has to be offset to the left in the longitudinal direction. We cannot use the carriage, as this is in engagement with the lead screw during thread cutting. I will now use a test piece to demonstrate how this longitudinal offset can be achieved by a combination of feeds on the cross and compound slide. I start with a scratch pass, pull back the cross slide, return to the starting position and re-zero the cross slide. Now the actual longitudinal offset takes place. In the first step, I feed the cross slide in by about twice the desired longitudinal offset, in this example by 2 mm. In the second step, the compound slide is moved back beyond the zero line. The carriage is now moved back into the area of the workpiece, and the compound slide is advanced so far that the tool just touches the workpiece. This sets the desired longitudinal offset. The offset can be calculated as tangent of 30 degrees times the cross feed. This should give us 1.15 millimeters. We check this with another scratch pass. So cross slide back, carriage back to the starting position, cross slide back to zero, minimal infeed on the compound slide, and scratch pass. The caliper gauge is used to verify that the two scratch marks are indeed offset by the expected 1.15 millimeters. Back to our actual workpiece. I messed up a bit here, so please forget this scene. But now, cross slide to zero. Feed in the cross slide. Move the compound slide back. Zero the compound slide. For a test run, feed in the compound slide a little bit and try a scratch pass. As I made a mess before, it's hard to tell, but it looks okay. So I feed in on the compound slide and cut the next pass. This is now repeated several times, and after a few passes you can see that something like a second thread evolves. At some point, the two threads merge and the right flank of the thread cutter approaches the thread flank cut in the first passes. Towards the end, it is advisable to reduce the infeed to avoid unwanted cutting and chatter on the right-hand side of the tool. After the first longitudinal offset, the thread is now cut to the maximum depth and another longitudinal offset is performed. So again, advance the cross slide by 2 mm. Move the compound slide back beyond the 0 line. Zero the compound slide on the workpiece. Feed minimally. And scratch bars. The new thread is clearly recognizable. The entire process is now repeated for the new longitudinal position. Admittedly, the method is extremely time-consuming and requires a certain amount of concentration at first. On the other hand, it makes it possible to produce threads that would otherwise be almost impossible to make on small lathes. Now it's time for another longitudinal offset. Adjust the cross side by 2 mm. Move the compound slide back over the 0 line. Zero the compound slide on the workpiece. And so on. Only a smaller step size is required for the last longitudinal offset. The resulting smaller cutting width then allows larger infeeds on the compound slide. By the way, I do not claim to have invented this method. A similar procedure is described, for example, in the book Spindles from the Workshop Practice series. The efforts are finally rewarded by a quite usable thread. I would be delighted if this little trick would be of use to small lathe owners. Thanks for watching and see you next time.